Hello everyone, welcome to new class. Today's class is the continuation of the network theorems. We are discussing about the Norton's theorem. So today's class is about the problems related to Norton's theorem. Let us go through the problems. What is the current in the 5 ohm resistor? Use Norton's theorem. So that is the 5 ohm resistor. So we have to find the current in the 5 ohm resistor. So while applying Norton's theorem, our first step is to find ISC, that is the short circuit current. To find the short circuit current, we have to short the resistor and find the current ISC. So for that, redraw the given circuit diagram. So here we have to short the 5 ohm resistor and this is current ISC and this is 1 ohm, this is 2 ohm, 10 volt, 2 ampere and this is 2 ohm resistor. And here while short circuiting this branch, this 2 ohm resistor will also be short circuited. So no need to draw the 2 ohm resistor. So this is the new circuit diagram after short circuiting the 5 ohm resistor. Now we have to find the value of current ISC. So for that, here there are two loops. This is first loop and this is the second loop. So from the first loop, we have current. Let I1 be the current in the first loop, I2 be the current in the second loop. So from the first loop, current I1 is equal to, this is 2 ampere current source. So I1 is equal to 2 ampere. Then from the second loop, let us apply KVL, that is Kirchhoff's voltage law, to second loop. Then we will get, this is minus 2 plus, so we can write 10, then minus or 10 equal to, here this is I2 and which is same as ISC. Then here there is 2 ohm resistor, so we can write 10 is equal to 2 into current through this 2 ohm resistor is the difference of I1 and I2. So we can write 2 into ISC minus I1 and that is equal to 2 ISC minus 2 I1 and here I1 is 2 ampere. So we can write 2 ISC minus 2 into 2, that is 4. So from here we get 2 ISC equal to 10 plus 4, that is 14. So ISC is equal to 14 divided by 2, that is 7 ampere. So ISC, that is the short circuit current, is 7 ampere. We can denote ISC or IN, that is the Norton's current. Then next step is to find R internal, that is R internal or Rn. So to find the internal resistance or the Norton's equivalent resistance, we have to remove the 5 ohm resistor and also deactivate the given sources. So for that, redraw the circuit diagram. So for the current source, we have to open that current source, then 1 ohm resistor, 2 ohm resistor, then for the voltage source, short circuit it, then here 2 ohm resistor, then here 5 ohm resistor we have to remove and find R internal. So this is 1 ohm, then 2 ohm, here also 2 ohm. So this is the circuit diagram after removing the sources. So here this current source is open circuited and voltage source is short circuited, and this 1 ohm resistor has no effect because this is open circuited, and R internal is equal to, these two resistors are in parallel. So R internal is equal to 2 into 2 divided by 2 plus 2, that is equal to 1 ohm. So R internal is 1 ohm. So next step is to find the equivalent Norton's circuit diagram. So for that, draw ISC, that is 7 ampere, which is in parallel with R internal, that is 1 ohm. So this is the equivalent circuit diagram, and to find the current through the 5 ohm resistor, we have to connect this 5 ohm resistor in parallel. So this is 5 ohm resistor. So this is 7 ampere current source. Now we have to find the value of current through this 5 ohm resistor. Let it be IL. So IL is equal to total current into, that is 7 into resistance through the other branch divided by total resistance, that is 6, and that is equal to 1.17 ampere. So in this way we are applying the Norton's theorem and finding the value of current. Let us do another problem. Find Norton's equivalent circuit at the terminal XY. So this is the given circuit diagram, and we have to find Norton's equivalent circuit only. No need to find the current or voltage any. So first of all, our first step is to find the short circuit current ISC. So for that, short circuit the terminals and redraw the given circuit diagram. So here we have to short circuit this XY terminals, and this is 5 angle minus 30 volt, then this is minus J 50 ohm, and here while short circuiting this terminal, this branch will be short circuited. So no need to draw the branch, and this is ISC. So what is ISC? So ISC is equal to V divided by X or V divided by Z, and that is equal to 5 angle minus 30 divided by minus J 50, and that is equal to 5 angle minus 30 divided by minus J 50. We have to convert into polar form, and in polar form we will get 50 angle minus 90 degree, and the conversion we have already discussed, and if you didn't watch, please go through it, and the link will be given in the description box, and that is equal to 5 divided by 50 is 0.1, then minus 30, then plus 90, that is angle 60 degree, that much ampere. So ISC is equal to 0.1 angle 60 degree ampere. In the next step, we have to find R internal. So to find R internal, we have to deactivate the sources. So here there is only one voltage source, so we have to short circuit it. So after short circuiting, we will get the new circuit diagram is like this, and here this is XY terminal. So this is minus J 50 ohm, J 200 ohm, this is 200 ohm. So what is R internal? Here these two are in parallel. So we can write R internal is equal to minus J 50 is in parallel with 200 plus J200. So here we can write minus J50 into 200 plus J200, then divided by minus J50 plus 200 plus J200. So here after computing we will get multiply minus J50 with this 200 plus J200 and simplify. Then we will get 200 minus J200 divided by 4 plus 3J. So again we have to convert this rectangular form into polar form. Then we will get 282.84 angle minus 45 divided by 5 angle 36.87, and that is equal to 56.57 angle minus 81.87 ohm. So this is our internal. Now the question is to draw the Norton's equivalent circuit. For that, first of all, draw the ISC. ISC is 0.1 angle 60 degree ampere. Then in parallel with the internal resistance, that is 56.57 angle minus 81.87 ohm. And here we have to draw the XY terminals. So this is the equivalent Norton circuit diagram. Let us do another problem. Find Norton's equivalent circuit for the given circuit. So this is the given circuit diagram, and here we have to find the Norton's equivalent circuit only. No need to find the current or voltage, anything. So here the given terminals are A and B. So across these two terminals we have to find the equivalent circuit. So for that our first step is find ISC, that is find short circuit current. For that, short circuit the terminals A, B. So redraw the circuit diagram. So this is 5 angle 0 current source. Then this is J5 ohm, this is 2 ohm, and this is 4 ohm resistor. Then capacitor. Then the terminals A, B. So this is minus J2 ohm, and in the first step we have to short circuit these terminals. So while short circuiting these terminals, this capacitor will be also short circuited. So the circuit diagram will be like this. So this is current ISC. Now we have to find the value of ISC, and ISC is equal to, so here this is current source, so we can apply the current division rule. So that is the total current into the resistance through the other branch, that is this is the impedance, that is 2 plus J5 divided by total resistance. So here total resistance is this 4 plus 2, that is 6 plus J5. So this is the total resistance, and here we have to convert this rectangular to polar form. So we will get 5 angle 0 into 5.39 angle 68.19 divided by 7.81 angle 39.8. So after computing, that is 5 into 5.39 divided by 7.81, we will get 3.45 angle here 68.19 minus 39.8 we have to do, and we will get 28.39 amperes. So this is ISC. Now we have to find R internal. So to find R internal, we have to deactivate the sources. So here this is current source. So we have to open this current source and redraw the circuit diagram. So after deactivating this current source, we will get the circuit diagram like this. So across these two terminals, that is AB, we have to find R internal. So R internal is equal to, and here these three are in series, which is in parallel with this minus J2 ohm. So we can write 4 plus 2, that is 6 plus J5 in parallel with minus J2. So here we will get 6 plus J5 into minus J2 divided by 6 plus J5 minus J2. And that is equal to, here after multiplying we will get minus J12 plus 10 divided by here 6 plus J3, and that is equal to, convert into polar form, that is 15.62 angle minus 50.19 divided by 6.71 angle 26.57, and that is equal to 2.33 angle minus 76.76, that much ohm. This is the R internal. Now Norton's equivalent circuit diagram is drawn with ISC, that is 3.45 angle 28.39 ampere in parallel with R internal, that is 2.33 angle minus 76.76 ohm. So this is the Norton's equivalent circuit. So in this way we are applying the Norton's theorem. So first step is find ISC, that is short circuit current, then find the Norton's equivalent resistance, then find the Norton's equivalent circuit diagram with ISC in parallel with the internal resistance. So this is about the Norton's theorem. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.